Hello everyone, welcome to this 14th video on Python. In this video, we'll discuss how we can create plots quickly using pandas. And we generally use pandas for reading different files, writing different files, doing the data transformation, and summarizing the data. But we can also use it effectively to create some plots as well. So let's see how we can do that. And I will share the link of the dataset being used here and the official documentation as well in this Jupyter script, which will be available on GitHub. So you can download it and run it on your system as well. So this pandas plot, it has these many arguments: x, y, kind. So kind is the important one, where you specify what kind of plot do you want. For example, line would be for line plot, bar would be for vertical bar plot, bar would be for horizontal bar plot, hist for histogram, and box for box plot. So we'll cover scatter, bar plot, histogram, box plot in this video. And there are many other arguments as well, which you can take a look at, because many of them are to modify your plot, so you can use them as per your requirement. So let's start. So we'll import this libraries pandas, and then we are reading this dataset, which is brain stroke dataset, which is available on Kaggle. So just after loading, we'll take a look at the shape of the data frame, and we have 4981 rows with 11 columns. And if you do head, you can see what all these columns are. So we have a gender column, age column, a flag whether that particular person has hypertension or not, heart disease or not, was ever married or not, what is the work type, whether it is private, self employed, government job, or any other work type, residence, whether it is urban, rural, average glucose level, BMI, smoking status, and stroke. Okay. So this set of information is available in that data set. We can analyze the data in many ways, but I, for this purpose of this video, I've used a few columns to understand how we can create different kind of plots using pandas. So let's start with scatter plot. So in scatter plot, we actually look at the distribution across two variables. So from there we can understand even the if there is any correlation between these two variables or not by looking at this scatter plot. So to do that, we'll use data frame df.plot, and we'll mention which column we want on the x-axis, which column we want on the y-axis, and we'll also mention that it is a scatter plot when we are doing just df.plot. If you do df.plot.scatter, then you just need to mention what is in x column, x-axis, and what is in y-axis. Another important arguments are alpha, which is for used for transparency, color, size, marker type. These are the other important arguments. So if you look at this plot which is created here, it's df plot, where I have mentioned x to be age, y to be average glucose level, kind scatter, alpha equal to zero point 0.2, color equal to red, size 0.5, and marker as star. And then I've also mentioned the title, so you can directly add the title in this uh, function itself, and x level and y level. So at least this much we should add, so that we understand the plot is related to what and which variables are there on x and y axis. Now we can see this plot here. If you want to change the color to say blue, and then size to zero point 0.8, let's see how does the results look like. So with these changes, you see, we may not notice change in size, but yeah, color has changed to blue. So let's change this marker type to V and increase the size to 10 and see how the results look like. So we'll observe now that it will change to triangle shapes with big triangles we can see. So here we can also change this marker type size as per our requirement. Okay. Now look at the other way of plotting scatter plot. So we can use df.plot.scatter, and here we have BMI on x-axis, average glucose level. This alpha is zero point 0.8 red and with size zero point 0.5 and marker star. So again, let's change it to 10 and let's look at again the triangle and see how it looks like. So, so you can see that we have these triangles now, and here if you see the difference that alpha was zero point 0.2 here, so this triangles were transparent. Now because alpha is zero point 0.8 here, these triangles are not transparent, they are very dark, and based on your requirement also you can make this adjustment in your plot. Now let's see how we can create bar plots. So again, two different ways. One is df.plot, where you specify the x column, the y column, and you mention the kind equal to bar, and then df.plot.bar, where you just mention the x and y column. One thing to note is that it can be created using summarized data. So if you just have a raw data set, you won't be able to create a bar plot. So to do that, you will have to summarize it based on your requirement. So for example, here if you want to see the number of heart disease patient by different work type. Okay, so we'll summarize the data first using group by on work type. We'll take heart disease, which is a 0 1 column, and then aggregate on sum. And we also sort values so that we have the highest number at the top. So the result looks like this. So private has 157 cases, self-employed 81, government job 36, and children 1. And if we have to plot this with the summarized data set, we can directly use dot plot, df summarize dot plot. We just have to mention kind equal to bar, then color, and the titles x label, y label you can mention, and this rotation equal to 30, which will rotate this x axis. Okay, so with this uh, lines of code, we can get a bar chart like this. We can also get the same bar chart using this summarize data dot plot dot bar, where you just need to mention which color and the title, the work type, sorry, x label as work type and y label as count. The index here is used as the x axis, while the other column is used as the y axis. So when we summarize the data here, we we didn't do reset index. So that's why this work type remains as index, and we just only have one column where we have these numbers. So because of that, we can easily get this plot just by doing df.sum.plot.bar. You don't even need to mention what is on x-axis and what is on y-axis. Now if you want to create a horizontal bar plot, again two different ways: df.plot, where you have to mention kind equal to bar h, or df.plot.bar h. And this also can be created only on summarized data. So again, we are just summarizing on work type, and heart disease, and will aggregating as sum because it's a 1 0 kind of column, and here we are sorting the values by ascending order because the number which is the lowest will be close to the axis. So if you do by ascending order, and if you do plot df dot sum dot plot, and where we are mentioning kind as bar, color as magenta, and we just have to mention title x label y label because this is again a summarized data set with work type as index. So index is directly used as y-axis, and the column which is present with the values, it is being used as the x-axis. So we get this type of plot. Okay, and one thing to note, because we want to have the highest value at the top, that's why we have just sorted it in ascending order. Now there are some variations of bar plot which you can do. One is stacked, the other one is dodged. So let's see how these different bar plot look like. So again, first of all, we have to summarize the data. So we are summarizing the data by work type and gender both, with heart disease as the column on which we are aggregating to get the number of patients. So we have government job as work type, number of females 13 and male 23. And this we have achieved by doing unstack on this summarized data frame. Because in the summarized data frame, because you are grouping by work type and gender, you'll get them in different rows. But the moment you unstack it, this gender column actually becomes two different columns. So this is how you can use unstack. And to create any stacked or dodged bar plot, we'll have to have those values in different columns. So that is why this is done. So we have one column for female and one column for male. And now we can easily create a stacked bar plot. So we will use this df summarize dot plot kind equal to bar. So the kind here would be bar only, and we just have to specify that for male we want blue color, for female we want pink color, and stacked equal to true. Because if we keep the color same, then we won't be able to differentiate, and by default you don't want to get some random color. So just specify the color so that it is very clear to you which of these values are for male and which of these values are for female. And then we have the title, work type, x level, y level, and rotation. So with these arguments we get a plot like this. So this is a stacked bar chart where we you have one category on top of other like that. Okay, in dodged you will have one category on side by side to other. So for that, again with this summarized data where we have two different columns for female and male, we can easily get a dodged bar plot where we'll have to just mention stacked equal to false, and rest of the argument you can change as per your requirement. So here you can see in government job the male is higher, in private job also the male is higher, in self-employed male is higher, in children there is only one male. And there are different use cases where you would prefer one type of chart over another, because here the comparison is a bit difficult in stacked one. So you, if you have to do comparison, you would like to create a DOS bar chart. You would go for a stacked bar chart if you just want to see if one is greater than the other. That's all. You don't want, you're not very much concerned about the exact difference between them. But here you can observe the exact difference as well. Now you can also present the same thing in a different way using subplot, where you will have two different chart, one for female and one for male. So how do we do that? So again, df dot summarize plot kind equal to bar, you mention the color, and here you just mention subplots equal to 2. Don't do anything to this argument which is stacked, and just play with this subplot argument, and you just mention subplot equal to true. So you'll have two charts, one below the other, one for female, one for male, and the x-axis actually remains the same, common between these two charts. Now if you want 100% stacked bar plot, then you can do that as well, but before creating that 100% bar plot, you'll have to do some data transformations. So we have this male female column. We'll add a column all, which is the sum of these two. And then we can calculate the percentage of male and percentage of female. Okay, by this work type. So once this calculation is done, actually you can just do a stacked plot, but you will pick these two columns to plot. Okay, so when I am selecting this DF summarized, I am selecting only these two columns, male percentage and female percentage. And then I am doing a plot and I'm specifying the colors, mentioning stacked equal to true. With all these, I am able to get a 100% stacked bar chart. Now, let's see how we can create a very useful another different type of chart, which is histogram. So again, it can you can do it two ways. One is selecting the column and doing plot with kind equal to hist. You mention the number of bins you want, or you select the column and directly do plot dot hist and you mention the number of bins you want. So with age, we can create this plot like this. We mention kind histogram, number of bins 30, and the title as histogram of age for bins 30. So we can observe that we have around 250 people in the bucket, less than 60, actually less than 60 age bucket, and around less than 80 age bucket also we have good number of 200 plus people. We can also create the same plot in a different way. DF age column will pick that and then dot plot dot hist, and we can specify the number of bins, and it gives you the same result. We can also understand, get into the details of the distribution of a particular variable using box plot. So if you do box plot on this age variable, results look like this, where we can see that this line, so median is around 40 plus, and then these are the different quartiles. So it's 25th percentile, which is first quartile, this is median, this is 75th percentile value, third quartile value. So that also we can observe using box plot. So I hope you find this video useful, and now you can easily actually plot using pandas only while you are doing any analysis. So do like the video, subscribe my channel, and share it amongst your friends. Thank you. See you in the next video.